Hello. So today I'm gonna talk about a little bit about my recent coding experience with Anthropic Claude. Um, my son convinced me that Anthropic Claude is actually fairly good at coding, so I subscribed to it and tried it. Actually, I was teaching a class on one class and then moving to another class, and I had about 20 minutes a break. And during that time, I basically experimented, which was fairly impressive. So here is what I go. So today, what I'll implement is the RoboTrader with genetic algorithm. All right, and let me share first what I got here. So I was actually teaching genetic algorithm in my class, the first class, and then from that, I was basically teaching genetic algorithm as an example for the frozen lake game that um, um, I have done. And at the end, I was mentioning that, well, this genetic algorithm is actually also used for some hedge funds for the automated trading. Um, and so I was kind of curious, can I actually get a very simple code that illustrates how genetic algorithm trading can work? So I did the following. So here's my prompt. Here's a genetic simple algorithm code um, run on Google Colab to solve Frozen Lake game. It's a 4x4 maze solving game. I mean, it learned the internet, so it should probably know. Now I changed the name to something. But can you make a similar optimal trading genetic algorithm implementing from one stock buy, sell, hold, and in an IPYMB file? And I actually gave that code. Um, it's a very simple code. Let me just share you for that. Uh, It's actually so originally I was actually taught a reinforcement learning Q table approach of this code, and it's a very simple game to find the 4x4 maze. And then, as a variation, I was showing how a genetic algorithm implements that same game and do this. And I basically shared this particular code with with Claude to basically think. So I basically shows how genetic algorithm is being implemented. And then I asked Anthropic Claude to, can you actually make something like this? So I shared my prompt, and here's what it was thinking. So it reads it. Well, I'm glad that it liked my notebook of this tutorial. It's a very simple um, tutorial on showing, illustrating in a very simple example how genetic algorithm works. Okay, so it basically read it and then it analyzed my code. It has 16 states, 4 actions, and blah, 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 and all this. And and so it basically um, tried to create um, a trading algorithm that basically does it. Actually, to make life easy, I actually asked, I forgot to mention that it's a tutorial for my class, and um, can you add more detailed descriptions so that students can learn? So it basically added also description of it here, and you can see that all the steps, all the blocks that it does. So how does the code look like? Um, let's go back to the code and voila, here's the code. Okay, so this is a genetic algorithm, optimal stock trading, buy, sell, hold. It's an optimization inspired by biological methods and um, a simple stock trading algorithm. The frozen lake maze basically had 16, 4x4 matrix, 16 tiles and 4 actions. And the policy is like an array of 16 integers. And the fitness is the probability of reaching the goal, 0 or 1. Here, basically, it has 10 states of where the state of economy lies, like a serious bust or it's a boom or something like that. And then there's 3 actions, buy, hold, sell. And then the policy is basically 10 integers. Um, And the fitness is the total portfolio return. Okay. So 10 states, 10 integers, basically. So, um, well, it also benchmarks against the random search, whether how much random search will get you. So here are and at the stock, it basically retrieves from Yahoo Finance. So here is Yahoo Finance and all some of the helper libraries. It downloads prices from Yahoo Finance, basically. So Apple stock, AAPL, and a 5-day rolling return like this. It computes here, something like this. Um, this will be the state variable. And the idea is very simple. The recent trend is the only information agent uses to decide whether to buy, sell, or hold. Um, it's an illustrated example. Of course, one can make it fancier and more complex, but well, let's see how this works. So it's a ticker and using Yahoo Finance to download it. Look back period is 5. Get the return for that. Okay, so we have that. All right. So the trading environment stayed 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Some very bearish, blah, 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 to very bullish. Okay. Okay, so so we have 10 states depending on the state of the economy and 3 actions. And here, basically, you get the state. And yeah, here we go. And then let's run episodes. Okay, so compute the current stage, look up the action, and then execute the action. And then we compute the total percentage return, how much it grew, and all that. So it's basically running an episode. Okay, so so this is one episode. And then random search. So the random policy is just random 10 digits. And then evaluate the policy. You basically run it, and you can run it. Okay. 2,000 policies, and then see how this different 2,000 policy among them, whether you will get how good you will get. And evaluating return for 2,000 of them shouldn't take that long. Let's see. Okay, all right, so it's done. So the average return is 107. Okay, so and the best policies were really like this, from the worst to the best economic state, what you should do. Okay. Um, So one being buy, zero being hold, two being sell. Okay. So now let's go to the genetic algorithm. We evaluate, then keep the elite set, and then selection, crossover, mutation, and then the new generation and keep playing it. So it's probably more selectively getting the better genes or policies and pass it down to the next generation. So we have the crossover and mutation policy, just like we did in the frozen game. And then the genetic algorithm loop. It's basically now we start with just 200 DNA, the policies, and we go for 50 generations. And this part looks pretty much similar to what we have done in Frozen Game. Basically, just have a policy, evaluate, get the elite set, and then when we do the crossover to the next generation, the higher fitness score, the higher probability to be selected as one of the parent, and then we mutate, and then we get the policy population again, and then go to the next round. So what we do here is basically that. And you can see from generation one, so it keeps going to, okay. And it already looks at the average looks already better than the random search. Okay. 6, 7. Okay. It's not always guaranteed to be monotonically increasing, but in the long run average, it should be getting better than initially where it started, which was 107, which is like a random search. Uh, but you can see that it's getting better over time. Of course, there will be an upper bound limit, but um, basically searches the policies and keeps the better one and then pass it down to the next generation in some combination. Um, and you can see that somewhere around 500-ish, it's already, well, it goes up to 600. So it kind of goes back and forth between upper 500s and lower 600s, and it's passing through. So 25 generation has passed and it's already 640 percent, 640%, which is pretty good. Okay. All right. Okay, so 600, 640. So I guess it's kind of going back and forth, passing through 660%. And now we have about 10 more generations to go. Oh, it goes to 670, so it actually goes pretty good. Mhm. All right. Okay, we're almost there. 5 more to go. And it seems that we are safely in the 650% return kind of stage. Okay, I think we are done now. Okay, and ultimately we got somewhere over 600. So the average return 599%. And this is the best policy we could ever get. Okay, so here we can see the best policy. When it's very bearish, buy. When it's sort of bearish, sell. Mildly bearish, hold on to it. Slightly bearish, hold on to it. And then when it's flat, buy, sell, buy, mildly bearish. But when it's very bullish, sell. Isn't it interesting? You're actually at the very top or bottom. You have to do what's counterintuitive. Okay. So here is basically the convergence of the return. So you can see that the maximum is here, the average is here. So we are reaching around 600 something. Okay, and let's compare the buy and hold strategy. You can see that the buy and hold return strategy gets 236%, whereas the genetic algorithm policy actually got on average 550%. Okay. So, and you can see here when to buy. So the red is sell, green is buy. And you can see that the green signals are at the low and then sell at a little bit higher, and it keeps doing it rather smartly. All right. Okay, so this was basically Entropic Claude during my like 15-minute break time, actually converting my genetic algorithm for frozen lake game, turning it into an optimal stock trading algorithm. Thank you for watching this episode.